let's work part B of this present value problem. This is probably one of the more complex present value problems that I've seen. Okay, so here's the information. Suppose the term structure of risk-free interest rates is shown below. And what you can see is they gave us rates from years 1 through 20. Now we're only going to solve part B, and part B asks us to calculate the present value of receiving $500 per year with certainty at the end of the next 5 years. To find rates for the missing years in the table, we're asked to linearly interpolate between the years for which you don't know the rates. And then they say for years 4, and if you see here we're not given years 4, you average years 3 and 5. Okay, so right there we've got to average years 3 and 5. And I worked this ahead of time, but you can see up here the formula. What I did is I said take the value of cell I-16, which is the 3.2 rate, then add to it G16 and divide by 2. Okay, so if you do that, let me bring this to light here, you get 3.03. I can hit the F2 key. You can see the formula. It matches the formula you were looking at up here. Hit enter, and we've got that part solved. Okay, and then what we've got to do is calculate the present value. All right, so here's how I did it. There's the formula. I'm just going to do this with Excel formulas, and I'll call it up for you. So what am doing? I'm taking the rate, which is given in cell E16 is 1.99. The number of periods is given in cell E15 is 1. And the future value is E21. Now, I'm entering it as a negative because of the way Excel treats positive and negative values with time value of money functions. We're going to assume we're giving up the potential to have $500 a year from now, and in exchange we're going to get the present value of that amount. So if I enter this as a negative, the answer comes back as a positive number. So that's 490. Now at this point all I've got to do is copy that formula into the other cells. Okay, so I guess I could just copy this over and we should get all the answers. Alright, and probably I should format this. There, I'll format it like that, then bring these back to light. And that's the answer you're looking for part B. And again, it's just the same function every single time now that we know the rate. We're calculating the present value of each of those. Now, to determine the net present value of all of it, all you have to do then is sum the various amounts. Okay, now there is not a net present value function in Excel that I know of that would allow you to determine the net present value of a stream of flows when the rates are changing. So this is the only way I know how to solve this one.